Today we're going to go over solving equations with the variable on each side. So this is asking us to solve the equation. There's a few steps to follow, and these are actually listed a little bit later on in the presentation, so I'm going to skip to those right now. And what it says is there's several steps. There's 3 steps to solving an equation with variables on both sides. What you'd like to look at first is if each side is simplified or not. So if it is not, meaning all like terms on that side are combined, then you want to simplify the expressions on each side first. You also always want to use the distributive property first if you see the need to use it. If not, you don't need to use it every time, but only if you see the distributive property can be used. The next step would be to use either the addition or subtraction properties of equality to get the variables on one side and the numbers without the variables on the other side. And then you want to simplify. So we're going to be doing some moving around of terms and combining like terms across the equal sign. And then the last step would be to use the multiplication and or division property of equality to solve. So if you need to multiply or divide, depending on what the operation already is, you would do that last. So back to the equation, where we have 3w plus 2 equals 7w. Well, each side is already simplified. There's nothing that we can combine, so we're going to combine across the equal sign. Whenever I combine across the equal sign, I need to make sure that I'm doing the opposite operation, but since I'm combining like terms first, I want to take the entire term, not just the w, to be with the other w. So I'm going to take the 3w and move it to be with the 7w. And to do that, since 3w is positive, I'm going to subtract. So subtracting 3w. Whatever I do on one side, I'm going to do to the other. So now I have 2 equals 7w minus 3w, which is 4w. And then finally, I want to get ultimately my variable by itself, so I want to cancel out the 4 by dividing both sides by 4, since 4 times w is what that means. So if I do that, I get w equals 2/4, which we can simplify by dividing both parts by 2, and that would be my final answer. So 1/2 is my final answer. I always also want to plug it into w to make sure that one side equals the other. So if I did 3 times 1/2, that's 1.5. And 1.5 plus 2 is 3.5. So if I did 7 times 1/2 on the other side, that's 3.5. So I have 3.5 equals 3.5. So this is correct. So the next one, I'm going to want to combine the variables with each other as well as the numbers with each other. And I want 1 to be on one side and the numbers to be on the other side. So the easiest method here would be to take the 7a and move it, because I always want to try and eliminate any negatives if I can. So that would make it now plus 7a since it's minus, and I want to move the entire term over to be with the 5a. So now I have 12a. Now I want to do the same thing with the numbers. So since the a is already on the side with the 2, I want to get rid of the 2 by combining it with the 6. Since it's plus 2, I'm going to minus 2. So I have 12a equals 6 minus 2, or 4. And then I'm going to divide by 12. And again, we have a fraction that we can simplify, so we could divide both by 4 and get a is 1/3. Now the next one, we have x over 2 plus 1 and 1/4 x minus 6. We talked about this already in class, but x over 2 could actually be rewritten as 1/2 x plus 1, and then that's equal to 1/4 x minus 6, which makes it easier to combine the x's. So I want to combine the x's first. I probably want to take the 1/2, or actually the 1/4 x, since it's smaller, and bring it over to the 1/2 x, so I don't get any negatives. And that would mean I need to subtract it because it's positive, and I want to take the entire term and move it over to be with the other x. So 1/2 minus 1/4 is going to be basically 2/4 minus 1/4, which is 1/4. So 1/4 x plus 1 equals, and it said minus 6, so when I bring down the 6 I need to have a negative 6. Now I need to combine my numbers. So I'm going to subtract because it's plus, and I get 1/4 x equals negative 7. And to cancel out a fraction next to the variable, I'm going to multiply by the reciprocal. So 4 over 1 on each side. So negative 7 times 4 is 28, and 28 divided by 1 we don't have to write, so we would have x equals 28. I ran out of room here, so that came from there. Now we're going to solve a decimal equation, which doesn't change our process, so we're still going to combine the c terms together first. I would want to bring the 3.3c to be with the 1.3c because we never want to have 0 on any side. We always want to either have a variable or a number. So we were going to subtract 3.3c because that's positive. I'm going to move that over, so I get negative 2c, and that is equal to 2.8. So to get c by itself, my final step would be to divide by negative 2, because negative 2 times c is what the operation is, so the opposite operation. And I should get 1.4, and that is a negative 1.4 because we have one negative and one positive, so that makes it negative when I divide. The next one, I'm going to continue following my steps, so I'm going to see, so I'm going to want to simplify the right side because I can see that I can use the distributive property. So I want to make sure all my sides are simplified before I start combining like terms. So I'm going to simplify by distributing the 3 to both the 6 and the 2s. So 3 times 6 is 18, minus 3 times 2s would be 6s. And that is equal to 8s minus 10. So now I can start combining the variable terms. So I'm going to bring the 6s, and this is really up to you which one you want to bring to the other side. I'm doing 6s over to the 8s because the 6s was minus, so I don't want to do any negatives if I don't have to. So I cross out the 6s, I've moved it to be with the 8s. If I add that together, I get 14s minus 10 equals 18. And then I'm going to need to combine my numbers. So it's minus 10, so I would need to add 10 to both sides. And I get 14s equals 28. And then my goal is to always get the variable to be by itself. So 14 times s means I divide 14 on both sides, which gives me s equals 2. And then my next one underneath there, I'll make this a different color. I'm going to distribute again, because I see that I can distribute the negative 2. I can also distribute the 7 on the left side. So I need to rewrite now. I have 7 times n, or 7n, minus 7 times 1, or 7, equals negative 2 times 3, which is negative 6, plus negative 2 times n, negative 2n. Now I'm going to combine my like terms across the equal sign. Remember, I need to add if it's subtracting or subtract if it's adding or positive. So I cross that out because I've eliminated the 2n on that side, and I'm taking it and putting it with the 7n on the other side. So I have 9n minus 7 equals negative 6. Then I'm going to continue combining like terms by adding the 7 to the negative 6, and I have 9n equals 1. And my final step is to get the variable by itself, so I'm going to divide by 9. So n would be 1/9. Next, we're going to continue doing the same thing. There's some instances, though, however, where you might have similar or the same variable terms on both sides, so I will tell you what to do for those answers. So let's see if these are one of them. We're going to solve this like I would any equation. To start, I see the distributive property that I need to use, so I'm going to do that first. And that gives me 7x plus 5 times x, which is 5x, minus 5 times 1, which is 5. And then on that same side, the left side, I see that I can combine 12x or 7x plus 5x to get 12x. So I'm going to combine like terms on the same side before I combine like terms across the equal sign. Now, I want you to look at these for a second. 12x minus 5, is that the same thing as negative 5 plus 12x? Well, it is. Since it's the exact same thing, meaning the exact same variable terms, 12x and 12x, and the exact same sign and number, negative 5 and negative 5, I can actually stop solving if I see this case, and I say this is all numbers. Because if one side is the exact same as the other, we can plug in x is any number, and you will get the same answer on the other side. So we can say this is all numbers. All right, the next one, again, we're going to have to distribute first because we need to simplify the sides before we go across the equal sign. So I'm going to distribute 6 times y, 6y, minus 6 times 5, 30, equals 2 times 10, 20, plus 2 times 6, or 2 times 3y, 6y. Now here, we notice that we have the same variable terms. We have 6y, positive 6y, and positive 6y. Since they are the same, but our numbers are different, the negative 30 is not equal to 20, what we say for this particular case is the variables terms are going to cross themselves out. And when they cross themselves out, you're going to get a statement that doesn't make sense. Negative 30 does not equal 20. So since it is the same variable term but different number terms, I can say this has no solutions. So here's our steps again. You hopefully have written those down in your notes under key concepts. Now we're going to do a little bit different of a problem, thinking about perimeter of a figure. So perimeter of any figure, you have to add up all the sides. If I'm to find the value of x so that the figures have the same perimeter, I'm going to need to find the perimeter of one of the figures and put it equal to the perimeter of the other figure, and that will help me to solve for x. So if I look at the first rectangle here, 6 is labeled, so on top of that is also 6. X is labeled, so on the other side is also x. So if I add those together, x plus 6 plus 6, I'm going to get 2x plus 12. So that would represent the first figure's perimeter. And then the second figure's perimeter, we have x at the bottom, so the top is also x, and x to the right, so the left is also 2x plus 2 as well. So if we, again, add all these up, I have an x, a 2x, and a 2x. So that's x plus x is 2x, plus 4x is 6x, and then 6x plus 2 is 6x plus 4. So this side, or this figure, the perimeter is 6x plus 4. Now, if I were to solve this for x, since it says they want to be the same perimeters, I'm going to put this equal to the other expression. So 2x plus 12 is going to equal 6x plus 4. And now I can solve for x. So I'm going to combine like terms across the equal sign. So I need to subtract the 2x. I have 12 equals 4x plus 4. And now I'm going to subtract the 4 to combine with this 12. Not the 4 with the x, but the 4 alone. And I get 8 equals 4x. And then I'm going to divide by 4. So x equals 2. And that concludes the lesson for 2-4.